Okay. Make sure that everything is in order now. I hear nothing from myself, that's not good. And why is it?
Oh. Oh wow, hello.
One sec. I need to turn on the noise cancelling so that you guys don't have to hear my extremely loud, potentially. Oh! Yep. That's what we're fighting against. So I hope the one person who joined the stream is not doesn't have get the ear blown off. Oh god. Should have done that. In retrospect, I should have done that before I. Oh no, I should have muted myself before I tried that because I could have picked that up on the noise gauge of the OBS just fine. Hey, you live, you learn. Wait, also, let me test this really quick. If the chat is around. Chat's not around, chat. What's the hell? What's going on? Oh, I was wondering where was I before I started. Element. Huh? Okay, let me see what happened to my stream element. It should be showing up, but it is not. Yeah, I don't see chat popping up. Oh god. I have to do this on live? I think I have to do this live. Alright. Oh. was like doing stuff, and then I was like, why? Nothing's showing up. Oh, ho, 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 ho. Yeah, chat, I'm trying to get chat to back me back up on screen. Give me a hard minute there because I just bungled something up and now I don't know how to fix it either. Let me summon the bot just so that I can yeah, let me just summon the bot there just so that I can get to see what the heck I'm looking at. Hey, there we go. Okay, there we go. We look like ass. Oh god. Oh. At least I'm gonna make it look big so that everyone can see what I can see what I'm reading. I need to do that for the other one too. How you all doing? Oh, I know what I need to do, right? Probably the URL got refreshed. Yeah, I don't think about it. That's probably it. Okay, let me try with the idle one first so that you can see what I'm up to against. Oh wait, no, it's there. I can see it, but it's very faint. I don't know why. Opacity. The opacity slider. That son of a bitch. At least the other. Okay. There's one last time. Yeah. And what, like, is there or not? I'm not waiting no longer. It's been 6 minutes past the time. Let's start, get some work done. Alright. Right. Right, chat. Hey. Gonna be quite a day of just poking things around and hope for the best. Okay. Anything in that is not in black is not final. Final anything. If I can. Where the heck is what those next bit? Oh, look at that. Ah, may have to make so much stuff to lately. This is an M5, so it's a 3mm. Yeah. Totally forgot. I should have done that with the new one. Oh well, I skipped it. I need to remind myself. Oh, hello. One more. How your day? Yeah, that. And the one in green and orange here are what it called our early prototype. It was probably the first time I ever printed these parts, these one, and I make some changes. Small one, really. Unlike the tool head, the umbilical mount is pretty straightforward. And because I don't have many of these, so I have to reclaim these love every time I make a bracket for my cartographer to fit the 1.1 printed backplate. Now fighting in Clipboard to set it up. Oh boy. That doesn't sound good to me. Honestly, that's the one thing I'm worried about when it comes to me and setting up the beacon probe. I heard that it's easy. The show was it a bunch of creators made make tutorial for it, and it seemed easy. I don't know. I'll believe it when I see it. So here's how I'm planning to get the umbilical in place. So we got two of these sandwiched together like that, and I suppose I should mount it on the right this time, the left this time. I've been trying this all day, and honestly, it's been consuming my mind for the past little bit since the last stream. Yeah, this is all prototype anyway, so I'm not gonna bother cleaning up the goo and all that. Because remember, there's a what is it called drag chain here and drag change here. Oh, hi Omar. So got this little bit here to mount the let's start mounting stuff onto it, although I know I'm gonna take more off anyway. good. It would be good to know where everything stands. So I need an M8 here. I gotta have a M6 somewhere. Oh, it's M8, it's M8. This one is threaded into plastic. I don't think that people are gonna be taking these apart anytime soon once it's in place. So I'm happy to make it simple and just thread into plastic. That's not bad. And a little more torque, and I can do it with my hand, right? So. What's going on this in here now will be anyway. This box is gone. It's an LEO thing. Or either in that box or in this box. I'll remind myself that I need to remind myself that I already printed out some part and I chucked it in here. I think this is it. It is this thing. This is yeah, this we got the Stealth Changer team to thank for this. It's a LDO USB adapter. Oh, let's just split one source to like 6. Oh, I need to show it on camera. Alright, so here is the box. Unlike a certain manufacturer, they put all the connectors in a bag. Oh yeah. I'm gonna rub that on. If I manage to go get to Merc this next year, I'm gonna rub that on to E3D face so many times. This should go like that. Here we use some standoff. If I can grab to it, maybe I put it in the bottom. Say, I didn't thought of this. How high the standoff need to be? I need to check. We don't have much option either. We got. Yeah, I don't have much option at all. That's an easy stick then. It's a M3 by 15 by 6mm standoff here. There's already a plastic one posed on the plastic bit. Would bring us to the iFixit kit because I need a little first time I ever used this bit. Yeah, that's the one. Alright, I also make this thing. I'm gonna go on to the two head like that. Basically for the umbilical. Pretty easy to make. Put it there. Another cutter that but no, then I didn't go all the way through. Alright, like so. Now this all gonna be mounted. Actually, let's mount the cover on as well. Like that, just so that we can see what's on. Oh, the whole not exactly lining up because of the flex. Don't think there's too much to worry about there. Yeah, because I'm not planning to put any component in. And I'm not running the wire today. I'm just gonna test fit this part. So this cover was designed and was meant for protecting this part. This is a perfect time to mount them. Oh yeah, I can see the pose actually is slightly off. Need to make sure to write that down somewhere to make sure that these poses are as straight as possible. Also to do it like that there, I can only make it so easier. blessing and a curse that I make these plastics so thin, because I can flex them to make them to massage them in place. But because of that, it's also tend to warp a little bit when not warp a little bit. It can flex itself out of the way when I was putting things together. You win some, you lose some. Anyway, that is what it gonna look like at the back. Oh, this is the back cover here. That's just cover all of the electronic box up. But into it, there's a little lid. And just like the original, there is hole for some M3 insert. It's a heated insert. So we can just lash it on the bottom and just close up like that. That's the point. I'm not gonna put the heated insert in there just in case I want this in another color. Yellow is a bit too bright for my liking. Oops. One of the things that I'm gonna do now for this build that is different from the V1 is the use of these. These are GX12 aviation plugs with a twisting knob here. This would allow it to be a bit more secure in place so that it won't wiggle itself out of place during printing, which is a problem I have with some of the connector that I have on V1. So like what, out of 6 I got 2 of them is a dot, were dot. All right, I put it on this side. Now, when time comes to do the final one on, we will definitely need to put like the appropriate amount of wivel onto this back piece here, because once you put it in place here, you basically never gonna get them. You only way to get them out is to disassemble the back. Unlike the original Voron that use the spring T-nut, I'm just gonna use the normal stuff here, because spring T5 M5 T-nut are horrible to take out of the frame. And of course, unlike this prototype here, the final one will probably look a lot more colorful. Oh. I really should have. Another thing about it, I should have made 2 more to go over here, because that would allow me to like test all 4 positions that was meant for, instead of the 2 that I'm gonna do now, and then I have to redo all of it. This we'll do for that later. That is for later. That was easy. Okay. So, you can imagine. Yeah, put your hand through there, dealing with the wires. Okay, we brought this to the front. I'm gonna shove this one through the bottom swivel. Sweet. The one thing I noticed immediately is I get interfere with the track change here. Let's grab a track change and see how that go. Let's skip a couple of steps here. The track change. Nothing wrong with this track train. Want to break the meter? Right them up. A little stiff. Ah, there it is. They're trying to find a place to shove a screwdriver in and just run out like that. These need to be on the other side. Oh. Oh, no, it was right the first time. Oh, God. Alright, my bad. Just got it backward. Did I? Yeah, I did. I got it backward. I thought wrong of it. Alright, put this thing back on before I lose it. Down to some. No, make sure that's in the know to sleep. Yeah. Oh. Oh yeah. Had anyone here play Stealth song? That's basically my second new obsession beside this thing. Hurting my fingers too much playing that game actually. Now the good news is it's not as dramatic as I thought it would be. This is good. How far back can I fall? It's good. You can see that I can put my finger through like that. I mean, there's some space for me to mount stuff to this rail on top. I was worried that wouldn't be the case. Obviously, I thought I worry for nothing. Like if I pull back, like make sure that if I push this all the way up forward and pull the drag train all the way back, I don't think you can see it. If I put the gantry all the way forward and the drag chain all the way back, yeah, we will have like 2 finger of width here. So that's one thing that's good. Now if I try to drag this, also, let me grab this panel here really quick. Just drop this on top to see how the wire responds. This responds to what is it? Having one of those on. Oh. Oh, that's not good. What is it? Oh. That might not be good. With the restriction on the top and the side, what happens is that when you push this all the way back, this thing collapse into this well here, which is not good because that means it's going to interfere with the homing of at least the Y. How do I deal with this? Leaving the XY switches on the gantry. I'm gonna use the original XY was it PCB mount on the corner of the print here. So if this is right there, you can do X, and Y is independent of that. So that is one thing that is gonna be better for V2 at least, because when I do V1, the setup of the original kit was to have the X switch on the tool head. Didn't work for the tool changer obviously, so I had to swap to a little thing at the back. And once I'm done with that, I just didn't want to be bothered with adding new stuff to it. That's annoying. Because we can have it trying to have it swivel that other way, the other way. I try to do that. By just passing this, or do this hole instead. Oh wait, no. Pass to the back and see how that go. I'm holding out with my hand at the front here. I need to get the gantry off so that I don't crash onto my dog. Put the lid back on. Actually, I'm pulling it tight now, tighter than before. Yeah, that's what I'm worried about. Pop out to the left. So the only way to deal with that is to have it not over here. So imagine that, but on the right instead. So because if I have the it started from that side. And it's tight. When I pull it back, it's that instead. That is good because now it's fall within the boundary of the print volume, the machine volume. So let me remove that and just put it over here instead. Missed a full stop after stay on. It makes the sentence hard to read. Cool Thunder was able to flip the arm to others too. Look the other way when it is homing. Oh, you mean you mean the we want to see if the arm can flip the other way? Yeah, I'm doing it now. I'm trying to do this now. Basically there's 3 positions that I put into this prototype to see what fit. There's the middle one. There's and the 2 corner one. What we determined right now is which one is the least painful to deal with as for a what is it called? For the reference tool head, because this reference tool head gonna be the one that we use to home with. Well, I'm gonna use to do almost everything with. Every other tool head is gonna rely on this one. I need a tray. Tray is full. This one out. Missed it a full stop after stay on. Make it hard, the sentence hard to read. What's stay on? So if I put this over here, yes, so these can swivel around 120 something degrees, I think. Wait, no. That had them swivel like that. Yeah, this is how I designed it. Gonna stay. Oh, what I could have done, I could have just pull this over here and see how that goes. Okay, whatever. We done it anyway. And we do need the hole at the back. So top one. Interesting. Alright, in this configuration, it should dock over here. So my thinking is that one dock over there. That. And I'm gonna put this on. Now, for a single two-head system, this is perfect. But how are we doing this? How are we? When cable manage this? Because you can imagine, like the other one would go from there. There, that one will be still easy. So that the second one will be over here, while that one is doing that loop there. That is easy. That is simple. But what of the third one that is right over there? Why now? Okay. Alright, it's time to have some sacrificial PTFE2. Either that or I'm just not bothered cutting these at all, just run them through and made a mess in the corner. Yeah, let's do that. I don't want to cut this. Yeah, I'm just gonna chuck that the rest of them there. That's Phil. Future Vinny in about 20 minutes. No, in 3 hours time to figure it out. How to do with these, how to clean this up. Running this wire now. Oh, in case anyone wondering why not putting the electrical in it to figure things out as well, the answer would be is actually the answer to that is that the electrical cable have almost no resistance at all. It's always end up down to how the PTFE2 gonna do things. Just need to be fed in more. Wow, fed in a lot more. And also drooping is actually an asset, not really a problem. As long as you don't droop it way onto the part, that's also it's just very good. But if this one do that, and the third one gonna have trouble doing anything else if this one is not out of the way. I'm thinking. So we cannot intertwine the. So we cannot start here and go there. It has to. So it have to curve that way no matter what. Or they can all point that way. It's not symmetrical, obviously. They're not gonna look good. So it's not gonna look good, but it would be functioning if I have like all four of them, like in the there, but pointing that way, right? So all the tube lean that one, right? Stack it. This is perfect. That's my notepad. Oh, get up out of it. So if I one there, one there. Now this is in the dock position, right? This is in the dock position. The dock position. So if this is in the dock position, right, the other one coming out on the left, gonna under that like so. So if I go, so this one go like that. It's subtangling. Oh why not? Am I crazy? Alright, let's grab some of the prototype piece really quick. I think I might have just tripped myself into overthinking myself. This feels like this would work right. These are not quite correct, but they work fine for prototyping. I really have to cut this off. $30? Yeah, 3 by 30. Yep, good enough. Oh no, don't need to cut it. Grab the other one. Oh. So you know, we already established that this is not a good position, because if the two had come back, it's gonna be stuck like that, with all of this coming up or out, which is not good. Which is not good. That's what. Well, wasn't good before. Go the way to the end. No. Like that. Let's touch X. Oh no. Nope, it's immediately stopped up like that. That's why. Now, if it go like that, it's actually good. If it go in front of a huge track change, it would be nice. So if something was in the front, like so, to protect the track change from being to get caught, so from the PTFT to get caught from the track change, it would be nice, but it doesn't. It doesn't behave like that. So this thing need to be over here. So I'm simulating that two had been docked here. You can imagine. Over here actually. If I'm trying to move the two heads a little bit printing, you see that it grab on the floating two head. And then it twists back to normal. Oh yeah, I got turned. Yeah, twist. Good. Interesting. Maybe. Could you start two tubes at each corner point towards the mid-ish to lower and too high at the knot as to not tangle? Could you start from a corner point towards the mid-ish? So maybe you want to start from here and go in there, you mean? Yeah, could be. Let me try that. Well, actually, we can try that by... we can simulate that. With this guy. Now, the angle of this coming in is determined by the 2 point here that is attached. So right now I had a 2 point in opposite side. So no, so this one had the 2 point on opposite side. So there's a little hole here and there's a hole there. That's what determined that angle. And everything else have to move in accordance to that, obviously. Right now this thing go through the back, so straight at the back, like that. And first, so let me try this really quick. That works. I need some cable tie. Get some cable tie. I got one right there. Oh, right there. I'm just gonna zip tie the other one to where roughly where it's supposed to be. Easier. Give it some anchor point at least. Like that. It will go straight in from the back. Oh, so this is straight in from the back. Actually, straight in from the back seems like a appropriate one. Yeah, so it's escaped that one. So it's escaped this side here. This side during this, the only time that this thing we worry about tangle with anything is with the one die below it, which is going there. So let me test that now. By doing it on this other side. Wait. Just I felt so good that so lucky that I remember to I was not lazy enough to skip the shielding for the USB hub. Imagine all this poking around and then just scrape some sort of electrical pad off. Oh, that's going to be a bad day. Would have been a bad day. Okay. In the position you guys can see. So this one would be there. Oh yeah, so first put it back. So let's just put in, fold it the hook. So just hold it down like that. Hold it down so that it doesn't expand no more. Ooh, okay. Wait, if we have it coming in from the back, character limit, yeah, I have no clue how to deal with the character limit, not gonna lie. The only thing you can, like a split feed towards 2 over the motor A and B over. Oh, so you want to feed one over here, one on the left, and one feed on the right, right? Sort of like a yeah, flick 3.2 2 over near the point. Yeah, I know what you mean. I know what you mean. We can't simulate that because right now I could because there's no panel on it. I can just move it left and right. little ghetto. It could not swivel fully, but it will do. So what I was saying when I was doing the middle thing here, before I read your comment. No. So no, I think it's not it. A deceptive part about these route is that where it's about where you pinch the PTFE, right? So for example, actually let me do that run first. So the original plan was that had the PTFE tube coming through the whole swivel here, and it come through via this hole on the side. But what we discovered just immediately is the problem where if it bias too much towards that end, so i.e. if the whole PTFE tube is flexed on that like that, it would then get interfere with the drag chain. So that drag chain is probably the key problem, right? We have to deal with right now. So, and what I have done and what I realize now is we can control where that bias is by controlling the end of which it before it come here. So right now this is a one point of constraint. It was the other point of constraint was planned to be here, but now what if the point of constraint at the back here when I hold my finger? Yeah, if I hold my finger there, you can see that the PTFE tube immediately curved on the other way, right? So if the point of entry is actually literally direct straight from the back like that, we can get the PTFE tube to curve inward like so, which like this is fine because it does not interfere with anything. And between the PTFE tube is actually not a problem at all because the PTFE tube are they're pretty they're PTFE tube. They're gonna glide over each other at will, almost at will. And the reason why, and also one of the thing that just to answer one of your just to tell you why I was not I didn't do what you suggest immediately is because the theoretical shortest path between all point of this for the PTFE tube to be is at from the center point of the scan tree. So you imagine a triangle, right? You imagine a triangle. That path there. This is the furthest away that it can be, and the shortest is that, right? And I can't. God damn it, I can't explain it too well either. But yeah, you just have to believe me. Right there, it's a shortest distance to go. Oh no. This is this point is where you can have the shortest distance between the shortest difference between the longest point and the shortest point. The shortest point is right next to it, right this, and the longest point is right at the corner. If I had this at this corner, for example, this long distance going to be longer, so I'm actually pulled in quite a bit of PTFE tube now. You can see that it bulged up a lot more because when it got to the shortest distance. That's why I was keen to have the thing in the middle. Obviously, if I can get away with anything, I will get outwards. I have no attachment to any theory beyond practicality. So, if there is a better solution, I'm happy to take it. But yeah, so right now, this is the way to get the shortest one distance. You have to deal with the least amount of PTFE tube inside the chamber. Of course. Alright, let's put the lid back on really quick because I think that this is going to be my solution. So instead of feeding from this side and bias it so that way, I can just feed straight from the back and we can bias it like that. So now it's just do X and Y just fine. And now the only concern is what's going to happen to the one in the bottom. So let me run the other one. Yes, I don't want to Uh-huh. Oh. Oh wait. If you're on the top, then unit should be in the middle. That should note that to myself. The bottom button that should always on the outside. Let me swap the PD. I'm just take this off. So that one is gonna go to the loop. Just do this first. Let's do this. Let's do this. Run it first and then talk. Go there. So hold on to it. I don't have another 2 head just yet. Alright. The PTFE does itself have a different curvature, so we just twist this to see if I can make it better. Yeah, like that. It changed. Okay. So if it go like that, I'll grab the tube and then move it. That's fine. That's fine, by the way. So that it pushed the PTFE, the other PTFE tube out of the way. That's the key. It doesn't get tangled and yanked the disc off. And there's nothing holding on it at all, so it should have been easy to do so, but it didn't. Oh, caught my finger there. Try that again. So we'll go all the way back. It's clear the X and Y thingy switch. It gone in here, which is the top right. Ooh. I'm slightly concerned about this position. That's a very tight curve. Oh, no, it's not. No, it's not. Ooh, wait. It's got caught into this thing here. It got caught inside of this little loop here. Would that be a problem when I put a track chain on? One sec. Up the other track chain. Got myself some countersunk M3 here. Troop is good troops. Okay. About that, I don't want to be hunting for any what it's called, M3T not yet right now. Ooh, it's slightly off. Yeah, this platform need to be, the hole need to be pushing back like a millimeter or so. Yeah, these holes need to be pushed back that way, a millimeter. Alright, anyway, that's it doesn't matter. Right now, we need to deal with this. Oh my. That's it. In doubt, just add more zip tie. And that's two. Because I got plenty of these, and I don't want to go hunt for them three peanut. But right now, I'm gonna zip tie this side down. There. Okay, don't be an idiot. Just get some goddamn. Get some goddamn peanuts. It's right there, the box right there. Which was fine. The other one. Don't want to use the spring-the peanut. Don't want to accidentally scratch my frame just yet. Oh, I'm I opened the box and the separator got separated. Do you have any self-imposed constraint with the design, such as idea to avoid the need for a top hat, or will be a case where the whatever works? The reason why I'm against the top hat for this specific build is that I am I want to build a hotter machine, so I want to I want to raise the internal temperature of this machine up to like 70 or something and above. And to accomplish that, a top hat actually add more volume, more air to the to the chamber that will be required to heat up, because yeah. So yeah, top hat is, I'm trying to avoid it as much as possible. But if I have no other choice, yeah, it's alright. But even if I do have the top hat, I will still have to deal with this exact same problem. Because the one thing that I definitely do not like is the top hat that's too tall. Like, imagine the Bruiser XL, for example. That top hat is just almost as tall as machine itself. Which look like with, don't want to say the word, but it looks stupid. It is necessary, and it is the best way to get the wire out of the way. So I won't say that they did anything wrong. I just don't like it. And if I have to make a top hat, it also have to be. If I have to make the top hat, it will be clear as well. So if that would mean a more additional cost to trying to get the clear part in, which I also want to avoid because I already spent quite a bit of money already. So let's end with saying that we are making the best effort we could to avoid top hat, but I'm not that against it. And this strut chain looks good. Alright, let's back to messing about. Oh wow, don't trip yourself over those. Alright. Okay. Wait a minute. I just thought of something. That use that one. I'm gonna push this all the way to that side. That's why I haven't gone down the route of the Stealth Changer with my 2.4. Yeah, I would assume they got at least someone out there in community on the Stealth Changer community make a what's it called, clear top hat at this point, right, or something. I would assume. I haven't looked over it, but I assume that would be the case. You know what I said about the least amount of length? I had to eat my word there. Right. It's still very not very pleasant. Let's just try to get a different hold out. Let's use the other one really quick and go through this hole and at the bottom of. So this is basically the same as that, but pointing inward instead of outward. Out. Cut my fingers. Pull it all the way to the furthest position really quick to get the wire in. Like that. Put this over. Alright, so this is obviously best position there is. This is how something like a bamboo would run that single on a PTFE tube thing. Are you seeing the 2.4 people use a second 2.4 frame in panel, then store the filament top of the printer? Oh man, it's extra in the best way possible. Just remove this other one really quick. But of course, that's not my jam. Not my jam. I like. At some point, you gotta have you spend too much on this thing. Unfortunately, I already started asking that. Alright, so what happened here? I loop and I make the attachment point at the back there. And if this is single two-head printer, this is the best one, the best already. Would be the best position to. Wait, hello. Hello, wait. You see? Notice how it get deal with the traction. You guys see it that? So I just literally just put oil in here. Just I put the advantage hole at the back there. I just put it through that hole at the back there for the side, instead of pulling it from the back, and it was already stopped getting caught on the track chain here, which is nice. Nice. Alright, so I'm just gonna take that. I'm gonna shove this one in here. Okay, let's try my second one down now. There we go, like that. Okay, so that's one up to good. What did I say? Yes, it should be like that indeed. This one should droop. Okay. That one should be like that, right? Now I'm just gonna move this around. That one is easy to clear. Now notice here that this droop inward, so it doesn't go over the second one, the first one. So now I can move back. It doesn't do because of the one below it couldn't go over. Well, that's annoying. Now, yeah, they're interfering with each other. So this first one actually push the wait, can I just push it out? Yeah, this one on the bottom actually pushed the one on top outward a little bit more, so that now it got in and caught with it caught into between the track chain and the tool head again. Can I pull it? Can I get away with just pulling in out more? Yeah, can I get away with? Oh, now that worked. Try that again. I don't think you guys see it, but this thing it actually glide over this one instead of get caught under and get tangled. Watch. Okay, it did get caught under, but it's not over. Ideally, I want this to happen. I want this to fall over the second one, the one below it. This is ultimately what we want. Oh no. Just no, if it's too low, then it's caught in the mechanism. Yeah, like that. Yeah, so alright, that's wait, got down. Yeah. So naturally it just doesn't want to do that. But for whatever reason it managed to do not get caught by the track chain now. Still don't understand why though. Can't put the wood. Yeah, no, this is fine. This is fine. Let's go down and up and down. So the filament gonna be a little bit unhappy with how. Oh, hi Nick. I need another zip tie. Right there. Oh, there it is. These two are gonna keep the PTFE tube in place while I'm doing with another PTFE tube. There we go. Not exactly the correct position, but close enough. Alright, so that is the rough position of the first one. the cross to be right there, not up. Alright, let's do that again. Yeah, that's not good. It's running around. I put the PDB to the side. Well, this is the best possible location, right? Oh, I just run over the PAB tube now. Good. Wait, why do we have one poking out the back and one poking out from the front? Bend radius make me think there could be under extrusion in that back left corner. Yeah, that might be true. That might be true. That might be true. What's the point? What's the idea here? Well, how would we want the PDB to overlap? Right? In V1, they don't. Because there is because V1 over there, it's basically it's the because the gantry move up, we can imagine the Prusa XL. But with the space underneath the bed just collapse into with the wiring. That's basically how the wiring on V1 was done. That's why it was made. Can manage to make it so would fit all within the volume. But on the Trident, that we don't have that luxury. It becomes similar to the XL. What if we do away with this back panel idea and just mount it in the same way right there? But if we mount this right there instead. Yeah, maybe yes. Zip tie? No, we cannot zip tie this. There's gonna be a little bit challenge in term of like this. So it's coming up from the bottom, so it had to go similar to V1. It's coming up from the bottom, right? So the DB2 have to come up from like something like that. One over here and one over there. You know, this is actually much more straightforward method. So that means we need to feed from the bottom. Oh wait, no, but if you think about the bottom like that, why don't you just feed it from the side? Yes, just have it on the... No, because approach angle. The approach angle of this current panel right now is either straight in from the back with the hole at the back, or at an angle with two holes, one on the side and one on the swivel. Regardless, both we're gonna lay the PTP2 flat like that, and that is what's causing the problem right now, because it doesn't go flat. It after a certain amount of length, after it got compressed, it's gonna go it's for the side, it's gonna put itself to the side somewhere. So the idea right now, what I'm thinking is that, what if that pushing aside bit is done on the Z axis instead? So if it's similar with V1, if it go back all the way here, the excess wire gonna be pushed downward. It'll buckle the part down here. You guys don't see it. You're gonna buckle the part down in the Z. So like this was straight if it go when this thing at the front, right? But when it's pushed back, this one got buckled, and this length actually decreased. So that's just what we want to do. We can't do it here. I think we can. No, so V1 had a little what's it? Track chain, not track chain, little retractable cable just holding this PTP2 right here so that it doesn't fall into the pot. And move left. No, okay, never mind. Never mind. It's gonna extreme but throwing thing at the. I hope there's something gonna good from it. Oh, put the back of the enclosure above the gantry be made into a tube. Say, back of the enclosure make into a tube, 50mm deep, and have bowden feed from the outside, creating a little volume. Let the tube sit in it, and feed it to the rear. Something like that. Wait. So if I feed it, you guys see this, right? Fly. I think that I should have stick with this. So if I feed from here, go down and around like that, we just need a little stopper here and a stopper over here, and well, a holder over here, and go. left, down. Hold up. Might be onto something here. Because we don't have to go drastically on end to end like that. We can just do this. Just a little bit. Just a little bit. Oh, maybe not more than a bit. Like that. Ah. That is actually okay. No. We need that ledge. We need a ledge. We need a ledge. So we might still need a top hat, which is not a 20 centimeter one. Maybe like a what? 5 centimeter. So like just enough to this for this tube to pass through like that. Then it will do this the whole way through. So any excess just got shoved out of the back like a waterfall. Remember me, if you will, run the tube through the yellow thing again, but this time add 6 inch edge and move the tool head to the back left. I think it could avoid, but maybe enough radius. What? Where's that gone? I don't know what you're trying to say actually, but let me put this thing back anyway. Yeah, but anyway, I still like the way that I just did it, but regardless, we do need this extra electronic hub. So wait, remind me, we'll run the tube through the yellow thing again, but this time add extra now to head to the back left. That like that. Oh, you mean to see how much space you have there, right? It would hit the wall right there, and it's gonna bend up down like that at least. Yeah. No, along that same, that always seems like it's perfect. It's the key when it's the problem. The problem is not that any one of these runs is gonna work or not. The problem is when what they're gonna do when there's an extra one sitting in its way. There we go. That's one inside that. Yeah. Pull this one through a little bit so it doesn't fall out. We're gonna go back. Alright, let me put the lid on and see how that one reacts. Some of tube side. That's not too bad. I've smoking before. Why did it work now? Sorry, my absent. Your video was playing in the background, but Carlos was kicking my ass. Cut. Was alright, okay. Photographer kicking your ass. Was it that hard? Would it be really that hard? Yeah, the reason why this one was thrown out was because of this here. When it go like that, and it go out the front, it worked fine. What the fuck? Alright, yeah, no. Oh, this worked fine now. Why is that? You know, I think the more I do this, the more I think it's actually not bad right now. It's actually not bad. This one right now. So right now there's just enough for it to move around, like in both that's the one that is currently simulating the two head that being docked. That would be whatever T over there, and this one is a T right next to it. Actually not bad. Why is it working now? Assessing setup part is running 5 to head, giving you 5 times more error. Duplicate probe setting low. Ow. Oh boy, sounds like a nightmare. That's why I don't have to run into that. I'm just I haven't done anything of the setup in the software yet, but I'm just finger crossed I can just add a single beacon probe and call it a day. Like, just add the probe, and that probe will act independently of the two head, and that's it. Hoping to dear God that is the case. I'm gonna add the third one here. So this actually works somewhat, I think. Just to the top one? No, bottom one. I don't know. Hold on, delete for a while. This should be staying over here. Like that. So this is avoided all of that drama on that side. Actually, let's test this now. All of this could have done if I just decide not to run any cable management. So I have no. All this could be avoided if I just don't have a lid or a enclosure. Oh boy. Hold up. Just thought of something. What if I have a little arm in here like that? Just keeping this one section. Right? Just like a hook. Like a finger, the simulate where my hand is right now. Just like a hook like that. Doesn't interfere with anything. But it keeps this one from interfering with itself. That might be it. No, not just this one, with the one right next to it too. As long as there's a hook here. Oop. Yeah, there's a hook right here. Oh my. Yeah, that might be it. Let me just flip this around so that I got some touch. Yeah, as long as there's something here holding this part of the PFE from tripping down, this can run wherever it wants. Oh. Trying to think of a reason not to do this. Yeah. Nice. Bend radius. The bend radius is great, so let's go from there down. Let me run test another having an extra one right next to it. Because these two are not going to be bothered with the other two on the other side. That's a given. Okay. We'll take this one, shove it there. Good. Like that. Yeah, so if I have a little arm right there, holding just sitting there, doesn't no, it's right there, just sitting there with a little hook right there, just to make sure that the BFP2 don't fall out. I can run this all the way to that side, like so. Right, up all the corner. Would have been radius a little tight there, so that feeds some more. Alright, that's so. Oh, and let's put the lid back on for the compression part. Oh, this is a little, no, this is gone a little too out of it. Okay, never mind. Let me try all of that again. Oh wow. Well, I think I accidentally pulled through more than I should. 1 sec, need to redo this all. So this is it. It's the shortest length that it kind of I can afford it. So, do the next corner. Ooh. Ow, ow. Scraping my own arm. That might be the solution. Just add a bracket right there. That's it. Add a bracket right there with a hook. That's simpler than I thought. That's the also the waterfall idea that I thought of too. But let's keep that in the back for now, because that one requires to raise the panel up just a little bit. This out of the way. Yeah. Wait, how would you plug the? But no, because wait, no. Okay. Maybe not. Okay. How would you plug the umbilical cord into this socket here if there's a hook right there? The hook then it will need to be removable. The hook right there to keep the PTFE to not tangling with the rest of the frame. Oh, maybe it's quite deep around there. So at least a third of the way through, that's for sure. Oh, I have to make that for one in every two. And of course you did that. Oh no, actually, let me just if the hook closer further from that base, it can go up a little bit more. Do it. Can we do this? What does that to do? Ooh. So, counter to my own belief, I thought for sure if the hook is closer to the back, it's gonna work better. But around here is where it should be, about to a third of the way up. Oh. A little tight, but that's doable. Trying to think of a reason why I shouldn't do this yet. Give me a sec. You guys can see this, right? Go to see the edge of the table. And I need to get to the floor as well. Right, so the hook, the idea of the hook thing is right there. So there's coming right there. Just imagine there's like a little piece just sitting there like that. That's what I'm planning to build. You're gonna sit like that. This thing gonna fly. You can tell because ultimately the thing that got tangled is this thing getting tangled with the drag change. But it, oh, this corner here is a little bit dodgy because now it slot the PFT to slot itself into the well. Yeah, the PDFA got slot into the extrusion well. Can we reduce the length? Now, do we need to have a hook? Do we need to hold this right there? Because we don't, this thing can be a lot shorter than it was, and as long as it can come back like that, it should be fine. Because right now it's short enough so that it doesn't kink right there. But as long as this little platform is still here, we can still have this nice loop back onto the point. Oh. And and without that hook bit at the end, what this also means is that I can just pass the what's the connector, the umbilical, the electronic cabling through just pass over into the slot and onto their respective plug without much trouble. I think we found a solution. Just add a little tab right there. At least that's what we want to try. Oh, my back. Yep. Yeah. So let's grab myself some piece of something. Got this prototype cover here. Just simulate the tab. Like that. Nope. Okay, never mind. I need a longer than that. Need something longer than that. What do I have that is long and flat? Oh, got this. I should tilt down at an angle, don't I? You guys see that? There is a point where it starts kinking and curl. I don't know what that curl here is a good thing or bad thing. Also, this thing is still a little short. Let me get some sort of rod. Haven't you? Now let's just try using this 5mm rod, not cut myself in the arm. Try to use one piece. Where you done? Let's try this. Let's try this. Almost there. We got one working but very extreme solution, and we are trying to find one that require less finesse, I would say. Like that. Oh, why is it so tight? That might be it. Add a rod. A rod, long, hard rod. It's gonna piss the shit out of me when they do the printing. Oh, because you know, it's this specific point here where the thing flick upward like that. There's nothing wrong with that. I'm actually okay with that. But yeah. Alright, when this is dark, it's dark like that. Now let's just hold that up like that, like so. That's roughly how it's gonna feel. I'm gonna insert the second one right next to it. This one, see how they interact, because they could tangle with each other. The good thing about this specific setup is that the two on the left and the two on the right are independent in terms of like how they are gonna interact with each other within their section. That makes sense. I think they just not. And also, with all of this messing around with metal bits, I am surprised that this thing had not what it's called. I am surprised that the LDO frame hadn't scratched yet. Genuine surprise. This one can be a little shorter, like that. Yeah. So this is the dock position. Sorry, let me just test that again. want a gap in the middle so that this part here can actually go down, go up or down. You still want enough so that this section of the tube to be always caught in the under the on top of the rod. Because there's one going to be on the left, there's one on the right as well, so I want to add a little more. That. I'm going to spin these. Let's see what's going on in this corner. That's it. Pull a little bit more. I think that's as far as I want to go for the rod. Why is it keep? I think there's some what is it? Pulling force on the end there, so that it pushes itself out a little bit sometimes when I do pull back from here. I think that's good enough. Let's go the other way direction. See how that go. Ooh, that may not good. Alright, that's not good. So if we're gonna make this work, I need to make it go, be able to flip front like that. So the rod itself needs to move forward. That's actually not bad. Yeah, I can do that. So if it hook the rod like this, the PTFE2 cannot go over the rod, under the rod. It had to be, so the rod itself had to be pulled forward, and then it had to bring back like that. That would be required. That can be done. I can just add a little pivot point here and a spring or some of some sort, like a magnet spring or what. No, I got some spring coming in the middle. So I'm gonna have some spring pulling this in this position. So ultimately, alright, I don't get, because I got the thing right here with me and I don't. We're gonna have a pivot point here, a rod going there. I don't know how long that is. And there should be a stopper right there. So stop from stopping the rod from going that way, being pushed that way. But there should be a spring to keep it at that wall, and if needed, that rod gonna spring that way, yeah, and snap backward with the way it was. How far do we need to go? How far do we need to go? Okay, I think I just twist the PTFE tube there. Yeah, I think I just twist the PTFE tube on the two head side. Is that much? Oh. Uh-oh. That's not good. That's not a uncommon move, I would say. Okay, never mind. We might have to go with the waterfall. Yeah, we might have to just go with the waterfall plan. So what's the waterfall plan? The waterfall plan is to just raise this up about 5 centimeter. Oh, well, no, 2 centimeter, not that much. Even just the back, tilt it up about 2 centimeter, and have this pass through the back here. This is by far the cleanest way, but obviously there's a lot of modding around it. That's why I was trying to not do it. From the look of it, it's simple. It's a simple solution that is not that avoid the need of some specific pathing for the for the PTFE. But the PTFE tube start over here. If you give it this, can you see? Guys, see it? Actually, I don't know whether you can see it or not. One sec. Yeah, so if you give the PTFE tube this amount of space at the back, you can go almost. Well, just give it some more detail. No? Yeah. Yeah, if you give it all this space at the back here, you can actually just go anywhere, and when there's slack, it's gonna actually feed into the back panel instead of trying to navigate around the volume. So you can see, if you can push right there, you can see there, right? I think this is just the cleanest solution. The only downside is, once again, a lot of printing time, because I'm gonna need to print like 2 big hubs down here on the outside to cover up all this area that the 2 heads gonna take. And also, I'm pretty sure I might have broke the prototype. Yeah, I think I broke the prototype with all this yanking on the knob. Oopsie. Yeah, we do that. We do that. Oh, what time is it? I've been streaming for nearly 3 hours? What the hell? Time do fly when you're focusing, huh? So what have we learned today? Let's just write it. Let's summarize here. First, track change. This mounting point of the drag chain is not centered, so it needs to be pushed that way around 2-3 millimeter. Oh wow, about 6 centimeter. Okay. Yeah, the drag chain, the mounting point of the drag chain is like 6 centimeter off. I had to push it out to that side. And as for the PTFE, yeah, I think the cleanest solution is just to do the waterfall style thing. So we feed them over here. We have to loop down over. We don't need to extend the top, don't we? We just need to create a little hook here with a U-shaped hook right there, where the PTFE would pass through. So stay there, and it loop under behind the back panel. We may need a fold panel, Yeah, so it's gonna go like that. So we could stick with the solution for now. What else? And yeah, that's it. Insulation though, because obviously that may require the giant hole poking out of the side here. How do I insulate that? You can have an extra panel on behind the panel. I mean, that would hide the it would hide the electric wire that's coming up from the bottom. Wait. Convection insulation. Oh my god, I just thought of something. I can't. God damn it, I need some pen and paper. Oh, oh my god, I'm back. Oh. Convective insulation. So not when someone insulates something, it doesn't have to be airtight, because air is the most thermally inconductive material there is. Where is the marker? Yep. So think of this. So this is a cross section of this panel here, right there, right? Just imagine that. So this is the cross section of the this aluminum extrusion. Yeah. I'm gonna add a U-shaped hook right on the bottom there, like so that there's a hole there. So on a cross section, it's gonna look like that. So there's a hole going through there, right? If we have another panel just that stick out with some stand-ups to stick out like that, that obviously this is gonna be the channel where the PTFE tube gonna ride in and out. The thought in a second ago, let me just redraw this on this side actually. That's the thought that I was what I was worrying just a second ago was that the air that cold air gonna enter from this hole here, and then cause the chamber to cool down, because you know there's a giant path for the air to flow. But the thing about air is that hot air rises. So if this tube it's have hot air in it, this gap at the back have hot air in it, the hot air will be on the top. The cold air, the ambient cold air will be on the bottom, coming in. There would not be hot air flowing that way. There's no hot air gonna be pumped out that way unless you have an active pump to pump the hot air out that way. Does that make sense? I hope it does. That's the running theory at least. So in other words, just by having this barrier in this specific geometry, i.e. close up at the top, U-turn down like that, we effectively create a buffer zone of air mixture here, where the hot air is on top and when the cold air is bottom. And as long as the hot air, and the only way that air from actually enter this gap is when this air, that ambient air, is hotter than the air inside the machine, which is never. Or there's a drop in pressure within the chamber. So if the pressure drop, the delta P is positive. Delta P between the outside and the inside is positive. Then that means that then air can actually go up from the bottom. And that's actually a good thing, because the only way that's gonna happen is for me to pump the air out of the machine somehow. And that air and therefore got exchanged, right? That the cold air come in and the internal air come out. So yeah, that's a good thing, because I mean I can have a pump in the system to filter out the internal air and then have it pump outside, and fresh air gonna be thrown off from this gap inward here. So we got two birds with one stone there. So we create an inlet for a active air chamber, active temperature management, to for cold air to fresh air to come in, and while we still have this convection intervention here to prevent the hot air from leaving, and in a sense insulated the machine. I don't know if that makes any sense, but I think that makes sense. And yeah, I'm trying to think about how it can go wrong. One sec. I couldn't think of how it may go wrong. How thick the buffer zone is still gonna be a topic for debate. And how deep it is also a topic of concern. But I think we are good. We are good. Yeah. Wait. Where do I need to attach those then? Do I need to extend the panel? Because the aluminum extrusion had two sides, like it's a square block. So can I not just use... Imagine these are two acrylic panels. So this is the original one, just sticking out like that, right? If I have another one internally, just cover up the some of the area in here. Oh no, we can't do that, because then we don't have any channel for the PAB, so that you need to extend a bit out regardless. But that second thought there, just having using the internal PDB panel. No, acrylic panel. Okay, I take it back now. We need two custom panel, regardless. At least two. Actually, two is a good solution. If we have an internal one, i.e. having panel inside, we need two more inside. If you have an internal one, we're going to have two, because there's a Z-rod in the middle there. Z-rod in the middle there that we need to build around. So yeah, we're gonna use two acrylic panel for the back. One at that height. One a little short right there, and the other one with some reprinted thingy sticking out a couple millimeter. Let me see how far I can get away with though, once again. And I might actually just Alright, so let's try this side. Good and giggle. Yeah, I'm definitely rebuilding this tool head before actually testing anything like vibration and all that. So difficult. Okay, so it can go over there. That's good to know. That's not that big of a deal. What? Yeah. Me, I'm happy. That's it. Now they're just designing it. Oh, we need to design the. Oh man. Can we get away with just stopping the... We can get away with it. Now I'm thinking about scoring the acrylic panel out that came out of the box, and just chop off the top bit, and we mount everything else exactly the same. That way we can avoid having to order two extra one, which may not cost up to like 100 quid. Yeah. I wonder whoever works up still in business. Oh, damn. Trying to think now. Got it, my brain got scrambled a little bit. Ah. Oh, why is it not spinning? Alright. Yeah, my brain scrambled a little bit, so just give me a one mental break before ending the stream. Try a lot of solution, try to not extend the volume of the machine too much. I'm still against the top hat though, Not that I'm against it. It's a necessary evil if we'd need it. But I don't think we need it. Yeah, I don't think we need it. So we're gonna ditch. So ultimately, I'm gonna ditch that yellow box there. Oh no, we're not gonna ditch it. Actually, let's take it off so that we can cement to image here. Image going on. That now only carry electric box, electric hub. Yep, so gotta be mounted like that, and we're gonna build something around it. Oh, actually, that helped determine the height of this thing, huh? The height of the full protection. It's gonna be interesting to figure out how to do that without having them tangle with each other. That's not the height, the depth that much, the depth here. Oh, that would be roughly 40 mil. Avoid adding the top hat. The idea. Yeah. Go all the way to the front. The other one going up there. The other one gonna go there to that second one over there. Alright. And for the connector bit though, I think I'm gonna do a connector right there, I think. Oh no, then how do we gonna plug and unplug this? can have an access hatch open up like that. And then we can just yank unplug this right there, because this block is fun for it's person facing, right? Obviously, it's not gonna be as quick as V1, as nice looking as V1. This block here, well, first of all, it's out of line, sight out of mind for one, and there's a panel behind. When in actual use, there will be a panel behind it, so there shouldn't be. Flexing too. Don't flex too much, that's all. Right, so the idea is that there's something there. Yeah. Oh. Yeah. That worked. So we need an access hatch right there. So we can open this up. So we can open this up and disconnect the PTV tube and the wiring. So that's doable. At least if I look, at least from my position. So if you can see there, you can see over there. So it's gonna be where that box is right now, on the floor. So for me, I can just look over and open up from the back here, and do all of that. Can I do within the chamber? I think I'm living up to the description that I had give in my introduction video, where V1 is a normal printer that can turn into a 2-changer, and V2 is a 2-changer that can turn into a normal printer. Because for V1, it's very easy to convert back to a normal 1-2 system, while V2 is more difficult to do that, because it was meant to stay as a 2-changer for long. I'm trying to rationalize my own design choice right now. Okay, I need to break. I need this to a break now. But yeah, all things given, I think today was a success. Unless I can somehow access. Where? What if I can? Yeah, if I can access this panel without. So if I flip the electronic to go to the inside, stopping me from doing that then. rationalize my own decision, and now I'm trying to find my own way around it. Oh, never get enough, isn't it, Vinny? Come on. One last thing before I go. I want to flip it like that. Oh, wait. Bend the camera down so you can see what I'm doing. Oh. No, not that. Yeah, like that. No, wait. Just disconnect. Just disconnect the cabling at the tool head. There's nothing wrong with just going like this and yank the tool head out. Oh, okay. So let's check on this. Need to make a latch for this done though. I will need a latch for the electrical connector for that to happen. That's easy to make. See? Yeah, so disconnect right here. This what's it? I can't remember this. This 2 pin is for the power, and the other 2 is for data. And this thing does not have a locking mechanism, so this thing will fall out if you run too fast, especially if you have this thing rubbing against the top panel. So for me to be able to just plug this in and not and forget about it, I need to be able to lock this in somehow. Otherwise, it's gonna wiggle itself back and forth like that. And eventually, it's gonna fall out like that. For the PTB tube, though, that one is solved. That's a done deal. And if I do this, I don't need to think of some complex way to connect the cable. But I can always do this, right? Yeah, I don't need to deal with this. I don't need to deal with figure out how to run the cable neatly towards the front. I just can just plug it all at the back, and if we need to disconnect it, yank this out, and the PTB tube, and there we go. That's it. How long have I been streaming? I have been streaming for 3 hours sharp. Oh, alright. For real this time. I think we got the plan. I'm going with the back waterfall design for the umbilical. Gonna start designing towards that, basically ditching the old panel there, the old oh my god, the old PDAB panel, idea. It's just not possible to have an anchor point so close to the top. Because if you do an anchor point like that, it's going to the PDB tube. You're gonna need to negotiate with other PDB tube and on the top pan or near the top there section. There to and that's just not gonna end well. We can try to design a million ways to do it, but there's at least one way that the machine gonna move that is not accounted for, and it's gonna cause some problem with the print. So the waterfall design gonna account for all that, and in addition, it opened up another revenue, it support another design aspect that I was looking for anyway, and that is it gave me access an entry for the fresh air that would feed the active chamber management system. So if I need to cool the chamber down, I can just have two fan in the chamber pumping air out, and fresh air will be rushed up from that hole. So we got a plan. Oh, now it's just me getting it done. Still don't know how deep I need to get it to be. Maybe we try with some printed part first before we order any PTB for any acrylic panel. All right, no more. I'm gonna call it a night chat. Thank you everyone for hanging around, and yeah, I know a lot of you put the stream in the background just to support, so I'm not sure you can hear me or not, but genuinely thank you. And especially all of the what is it called, all the suggestions that we have in chat right now. It prompted me to think indifferently and think different I did. So yeah, wouldn't have thought that about this if it wasn't for you guys. With that, have a nice evening, everyone, and I'll see you on Friday. Cheers. They done.